Okay. So this is the first question. My screen is visible, right, to everyone?
Yes, sir.
Yeah.
Yes, sir.
So we are dealing with a NPN transistor, and mostly the problem will also be like both are almost same, but then also I'm just focusing on those topics only. Those are very important for the paper. Okay. So NPN transistor only, and you know already, right? If you have been this NPN, so and we have a resistance. Let's for example R2. So this type problems will be there where you will be given some VCC like some output voltage, not output voltage, some reference voltage has been given, and then here also the resistance can be given R1. Both will be grounded, and resistance here also. Okay. So the question is, let's for example the VCC given is 3 volt. Okay, and this is 60 kilo ohm. And beta, just think of as infinite. That means there is no base current. Now we have to tell me the value of R1 such that, maybe reverse it. Tell me the value of calculate R2 such that the IC current is 1 milliampere. See, this type of problem will be there, okay? It will be in the form of a comprehension. So, see, you already know that the pattern of the questions, every, like, first quiz you would have seen, right? 10 MC, like, true, false, and then 3 comprehension. So, in one of the comprehension, you can be given this type of questions, okay? And then from here, easily 4 5 questions can be made, right? The voltage here, or maybe like the output voltage, or maybe the VCE, or here you have been asked to calculate the R2. So this type of questions can be easily made 4 5 questions from a one BJT circuit. Okay, so similar type of problems will be there. So you can just practice this type of problems. Let's practice 2 3 at least. What will be the value of R2 here? R2, yeah, R2, correct. Anything else that you need? Nothing, right? Beta I already gave you.
So
IC
that
current
if
has been given.
beta is equals to alpha, or is it like too large?
Beta is infinite. It's very large.
Okay.
Large. I'm giving you some options. So let's for example A 20. But in the exam there won't be any option. All the questions will be NAT only. You need this one also, right? This is you can just think of as 0.7 volt itself. Are you solving?
Yes, sir.
Okay. Everyone try this. See,
Sir, whatever current will be in R1, that current will be in R2.
yeah, correct. The current here and the here current will be same because here you have IB equals to 0. So
Okay,
one
okay.
thing, one loop you can use here. Okay, here. Only thing that you need is the current here. Right? For calculating the current here in this circuit, we have to use this loop, right? So from this loop, you can calculate the current I. If you have the current, what else you need? The drop here, right? Because you already know zero point 0.7 drop is here. Zero point 0.7 plus zero point 0.5 something like 1 milliampere is going times 500 ohm, right? So zero point 0.5 here, zero point 0.5 volt here, zero point 0.7 volt here. So hold this point 1.2 drop should happen here, so that the loop, like the normal loop, the voltage in this loop will be zero, like whole voltage. So zero point 0.7 here, zero point 0.5 here. So zero point 0.2 drops should be happening here. So for zero point 0.2, sorry, 1.2 drop, you need the current here. If you have the current, I have already the voltage, you can calculate the resistance. To calculate the current, you have to come from here. So R1, you know, loop, you can use it from here, 3 volt. Here, whatever the drop will happen, like 60 kilo ohm times the time. And here also. So from here, you can calculate the current, and that current might help you to
Sir,
calculate
I
the
got 40.
resistance. 40. Yeah, 40 is correct. Correct. Anyone else? What is the current you have got?
Current 30 milliampere.
30 milliampere or 0.03.
Yes, sir.
Yeah. Okay. Anyone else who has tried? Okay. So, yeah. So you can use, so first equation, what I said, first equation you can use here itself, right? Correct? Let's say example. You're thinking that a current, okay, so that means plus minus, this is plus minus. Now you have to use the, in this loop you use, right? If you just use it, what will be the equation? Minus this thing, this is I, here also it will be I, minus I R2 plus 0.7 plus 500 0.5 times 1 equals to 0. So it will be what? IR2 equals to
Sir,
1.2.
there is one more easy method.
What is that?
We can
Signaling.
find, we know IE, so we can find the voltage there at node VE.
Yeah.
We can find VE,
Okay.
then
Okay.
it will get to plus. So 0.5 plus 0.7 will be 1.2,
Hmm.
and that will be 1.2. Then we can find current easily. Also, then we can do VB upon R2 is equals to that I.
Okay. So this voltage you are saying 2.5, right?
0.5, because IE will be 1 milliampere, right, sir?
Okay. Okay. Yeah. 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 0.1. Correct. This is 0.5, right?
And when we will go there, then it will get VB is equals to 0.5 plus 0.7.
That is what we did. Yeah, correct. So IR2 is 1.2, correct?
Yes, sir.
Yeah, IR2 is 1.2. Only thing that we need is ICA value, right? If we have the
No,
ICA value,
we can have I as 3 minus 1.2 upon 60 kilo.
correct. This is 3 minus 1.2, right? So I will be 3 minus 1.2 upon 60. That will be 0.03. So now you can calculate R2. 1.2 upon 0.03. That will be 40. Okay. And one more thing, I already told you two, three times, like everyone, whenever you are dealing in the BZT, right? So mostly try to
Sir,
write all the yeah,
sir, that kilo won't be there, right?
yeah, kilo ohm, yeah, correct.
Because we were getting 30 milliampere.
Here, eh?
Yes, sir.
No, see, resistance always try to write it in kilo ohm and current always in milliampere. The voltage will be in volt always, right? So here you have wrote volt like 3 volt, right? And 1.2 also is in volt, right? And this resistance is in what? Kilo ohm. So you will be getting always in milliampere. So whatever the value that you are getting, let's say you are getting 1.8 upon 60, right? So that will be in milliampere. Okay.
Okay, sir. Okay, sir.
So anywhere now in the BJT, in the exam also you don't try to write everything if this is in the form kilo ohm. You don't write it like 10 to the power 3 or something like that. Always write resistance. So here the resistance was 500 ohm, right? I wrote it like 0.5 kilo ohm. So that because I know that if I'll write everything in kilo ohm resistance and the current in milliampere, then voltage will always be in volt. Or so this three convention, if you are following, your current will be coming out to be milliampere. So you don't have to use like make the process lengthy. Like if you'll write it 10 to the power minus 3 and 10 to the power 3 every time, somewhere you'll do a mistake and your answer will be incorrect. So better you always follow this method. Always write resistance. So and you will see that whenever you are dealing with the bipolar junction, your resistance will always be in some kilo ohm and your current will coming out to be in some milliampere. Okay, and the volt will always be in the volt itself. So do not worry about the this kilo ohm or milliampere, all those things. You just write it as it is. But always think that you're writing in the form of a milliampere. Okay. If this is in even in ohm, then you try to write it in kilo ohm and then only write the equation. That will simplify everything. Okay. Is it clear to everyone? So
Yes,
this
sir.
type of problems will be there. Yeah. Correct. And I will let's solve one more problem. Question number two. So again, you have some reference voltage given 12 volt. Okay, so reference voltage has been given. Resistance also you just always I'll be writing in kilo ohm. So in the exam also it will be in the kilo ohm. So you don't have to worry about that. Okay. So let's say I'm writing 200 ohm. So you always write it as zero point 0.2 kilo ohm. Okay. In the equation when you'll be writing, just write it zero point 0.2. Don't worry about the kilo ohm or ohm. You just write it as zero point 0.2. So all the resistance must be in kilo ohm whenever you are dealing with BZT type of like if you are writing any equations or not. Okay. This is grounded. You have to calculate VC. So similarly, this problem will be there. You will be asked this current, IC current, IB current, I current, okay, and then you will be asked VC. So all those type of questions will be there in the comprehension type of a question. So this type of, so you just practice this type of questions, maybe two, three. That will suffice you. Okay. And always remember whenever you will be asked, okay, if I'm asking you VC, which point is that VC? Is it this point A or is it this point B?
B.
B, correct? And if I'm asking VC, VE, then this point, right? This is VE.
Yes, sir.
Yeah. So you have to find the potential at B point if you have been asked to calculate VC. If you have been asked to calculate VE, you have to ask calculate the potential at this point. I hope that is making sense to you. Because
Yes, sir.
some of you can have a confusion, you can directly write it as 12 volt. That is incorrect. You have to write it just like above the collector. Okay, you have been asked to calculate the collector potential, right, or voltage. So you have to calculate it at here. Okay, you can't write it as 12 volt, or you can't write VE as grounded like 0 volt. Okay, so I hope this is making sense. Now you have to calculate VCE.
Then we have to find VC and VE. So it will be VC minus.
Correct. That also you can do. Yeah, that is also possible. Anything else that you, B also is very high, and then this is zero point 0.7. This is zero point 0.7, and beta is very high. Very high. Okay, okay. So what will be the first? Tell me. Okay, just think of as a comprehension type of question. First, tell me the value of VCB. Then you have to calculate value of VCE. Like if you have, you can calculate, and already you know VBE, so you already know 0.7. So if you are able to calculate this, you'll be able to calculate the other one also. Correct? Calculate VCB. Okay, can somebody tell me the current IC? This not IC, this is IC. Can you tell me this current I?
Sir, I got
How
VCB as a 1.1.
1.1 is correct? Yeah, 1.1 is correct. So when if you are getting 1.1, that means VC will be 1.8, right? That's correct. Okay. Anyone else? How will you solve? Like, how will you think to solve this question?
First, we will find VB, which will we get R2 into 12 volt upon R2 plus R1. Then we will find VE. Then we will find IE. Then we will find VC.
Correct. Or see other method. If you are going from see this I can be calculated easily, right? 12 minus 0 upon 10. What will be the value of I? 12 here. If you are going like this, 12 minus 0 upon 10, 1.2, right? So this will be what? 1.2 milliampere. This current in 1.2 milliampere, that means the potential drop here is how much? 8 times 1.2, that is what? 9.6 volt. And the remaining drop will happen here, right? 2 times 1.2, so 2.4 volt. Is it clear to everyone? If 2.4 volt is like drop is here, right? If you just use the loop here, so minus 2.4 plus 0.7 equals to this current will be IC only, right? IC times plus IC times
Sir,
0.2
how did you
equals to
find that
0.
I?
I risk this. Okay. So you have 12 volt, right? 12 volt, you use the loop from 12 minus 0 upon the whole resistance, R equivalent. R equivalent is what? 8 kilo ohm plus 2 kilo ohm, right? 10,
Yes, sir. Yes, sir.
right? Or you can use the equation also minus 12 plus 8I plus 2I equals to 0, right? So 10I equals to 12, I equals to 1.2 milliampere. So 1 million. So now you have the current here, the potential drop you can calculate, drop here also you can calculate, right? So if you just want to write this equation, this is what you can just think of as 2.4 volt. Then you have how much? 0.7 volt. And then you have a resistance with IC current, correct? So you can write it as how? Minus 2.4 plus 0.7 plus IC times whatever is the resistance 0.2 equals to 0. So IC you can calculate. IC is how much? 2.4 minus 0.7. What is that? 1.6, right? 1.7, sorry. 1.7 upon 0.2. So you are getting 8.5 milliampere. Correct? So IC you got. Once you got the IC, then it becomes very simple, right? If you are getting IC equals to 8.5 milliampere, right? So now, what is the drop here? 8.5 volt,
Yes, sir.
right? So now you can use the loop here also, right, to calculate this VCB. VCB will be what? You just think of as this is 9.6, right? You just use the loop like this. So this is you just connect it as this VCB. Okay. So this will be somewhat like minus 9.6 volt plus 8.5 volt, correct? And VCB equals to 0. So VCB will be what? 1.1 volt. So this will be 1.1. If you have VCB, now you know already, right? This loop, the whole loop you can use. For BJT, you already know, right? You have VCB, you have VCE, and you have VBE, right? You already know that VC is what? VCB plus BE. You already know, right? VC, if you'll write it as VCB minus V plus VB minus VE. So this will get cancelled. You'll be left with VCE, correct? So this is what? 1.1 and this is 0.7. This will be 1.8. Is it clear to everyone, or should I explain it again?
Sir, one other way, because there is no base current, we could have also used the voltage divider without
Oh, you can
calculating
use
the
the
current.
voltage divider also. There also, if you use voltage divider, that also is, out of 12, how much is going to the 2? Yeah, that also you can use it. Because you need the potential here, right? But see, if you would have calculated like that, you know the potential here. Okay, you have the potential here also. Okay, no need of current, calculating current. Yeah, but in the exam, like in the comprehension, you'll be asked like, what is the value of I? What is the value of IC? What is the value of VCB? What is the value of VCE? So 4 5 question you can create it like from the same circuit itself. So this type of problems is highly prone to be asked in the paper. I hope you'll be able to solve it. Okay, is it clear to everyone?
Yes, sir. Sir, I just want to ask something which is not related to this course.
Yeah, yeah. What is like? Can we ask? Like, can you ask after the session after 10? Because I just thought,
Okay, sir.
okay,
Okay,
let's.
okay, okay.
Yeah, yeah. Okay, so try it out. This question, this will be the last question for at least for the BZT, like the basic BZT question, and then we'll solve from the mirroring. Okay, so similar question. Again, you have a 5 volt reference. I hope you have sent me the digital question, right? That is okay. I didn't look at that. Like, sorry. So I have to go through that. I just forgot. Now I 0.3 kilo. You see, you can be written like this 300 ohm. So do not take like whenever you are writing the equations and all, just take it as 0.3 kilo ohm. Whereas you have 4 kilo ohm, 1 kilo ohm, 2.2 kilo ohm. Calculate the value of IC and calculate VC. This is given as zero point 0.7. This is NPN transistor. What else you need? Nothing, right? Beta is very high. Hmm. Same similar question, but yeah, this is what will be asked. So try it out. This also much easier. No beta. If you have been given beta is very high, that means they're just telling you that the current, the base current is zero. Nothing else. Or infinite also it have been given. That means very high only, right? Beta is very high or infinite. That means the base current. They're just trying to tell you that base current is zero. See, if you are so BE should be in the forward bias. Okay, then only it will work in active region, right? Forward active region. Okay, so you can apply a voltage higher than zero point 0.7. But the only thing is the BE should be the BE should be forward bias. Okay. Yeah, so somebody is asking it is harder than quiz one, so it will be why I'm saying that the quiz two will be harder because for the first time you are dealing with the BJT clipper circuit and all. Mostly the clipper clamper and all will not be asked much, but basic idea you should be having. But BJT you're just reading for the first time, and then whole like 50% of the paper will be from BJT itself. So that's why I'm just asking you to practice at least this type of problem from the paper, like the assignment also. So that will be good for you. So to solve like 20 25 questions in 1 hour is challenging, right? So what is the answer you're getting? I see how much you're getting.
I see 1 milliampere.
1. Okay. And we see
We see as a 2.8, and 2.8 minus 0.3 means 2.5.
2.5. I guess that is correct. Yeah, that is correct. Again, same thing we can do, right? Have everybody solved this? Do you want me to solve or you can solve it? Again, the same process, whatever, like from the voltage divider, you can calculate the voltage across this 1 kilo ohm out of 5 volt. How much is the voltage? Is one only, right? 1 kilo ohm. And then you can use the loop here to calculate the IC. You'll be able to calculate the IC. Correct? See, this will be what? The potential drop is 1, so minus 1 volt plus 0.7 plus IC times 0.3 equals to 0. So IC is what? 1 milliampere only, right? And here you have a 4 volt of potential drop here, right? 4 here, and then you can again same thing you can use. This is VCB. VCB you can calculate, and then from there you can calculate VC. You have 4 volt here, so and you have 2.2 volt here, right? You can calculate the VCB from here. And then same thing, minus 4 plus 2.2 plus VCB equals to 0. VCB 1.8. If you have to calculate VCE, you can calculate VCB plus VB. This is 1.8 plus 0.7, 2.5. Is it clear to everyone?
Yes, sir.
Okay. So let's move to the next question. Everybody solved this, right? So if you're finding it difficult, just let me know. I don't think so this is difficult. Okay. Okay.
So can you solve questions from current mirror?
Yeah. Current mirror. So we're going there still. Yeah. So this should be the first set of comprehension that mostly will be asked. Okay. The second comprehension type of a question that can be asked is from the mirroring. Okay. So and one so I just want to clarify something. Let's say example you have a mirroring. So you have a let's say a resistance, R resistance.
So in the previous comprehension, if there is a beta is given, like not very high, but a value is given, then do we have to use some mesh analysis?
Mm, if you have been given beta, right? So even with the Thevenin also you can solve, right? You can
Sir, can you
calculate the
do
Thevenin.
one example with that?
Okay, we can do that. Okay,
Actually, the
we'll do that.
Thevenin one I
Yeah.
watched, but it was not clear to me.
We'll do that. We'll do that. Yeah. Okay, so I'll solve one problem with maybe some random beta value. That will also help. Okay, so first I'll just complete this mirroring thing. Okay, that is also important. So I'm just dealing with those type of problems that are very important for the quiz paper. I'll deal after mirroring. I'll solve that question, or maybe whatever the doubt that you have, we'll try to discuss that also. Uh, so in the mirroring, what happens? See, okay, so you have connection something like that, right? So this will work as a diode. This will be E, okay, and then you'll be having another. You can connect with some beta voltage B, let's example minus 10 volt. One more thing, just tell me whether this is I input, this is some current I. I see. This current I out. Let's say example is connected to some 10. What is the relation between I out and I
I
input?
out will be equal to I in,
If beta
approximately.
is very high. If
That
beta
situation,
was been
sir, that situation only works when beta is very high.
otherwise it will be in the form of I out will be somewhat like beta upon beta plus 2, something like that. If beta is very high, then only we can just remove this, beta will get cancelled, and then I out will be equals to I input. Okay. Otherwise, it will be in the form of beta upon beta plus 2.
Okay, sir.
Yeah.
Sir, but sir, are you listening?
What? I?
Sir, IC is always equals to I out,
Like,
but
yeah.
this
When
relation
the
is
beta is
valid for.
very, no, no, beta, when beta is very high, then you can write it as like the current out will be equals to IC. So, but the exact formula is this one. But even though you directly take it as I out and IC, for you, like I out and IC both will be same, right? It will be given in the problem that the beta that you are dealing with will be very high. Okay. See, you can just whenever the so I'm not complicating anything. You have been given, you'll be given the beta is very high. You just take it as I out as I reference, like whatever the I input is been given, you just take it I out, I in, same. Okay. See, beta, if beta is very small, there will be some IB and then the transistor will work very poor. Like, so if beta is very small, then the base current will come into picture and then the I out and I reference will not be same. Okay. Is it clear? So I hope this is making sense. Is it clear or not?
Yes, sir.
Hmm. Let's try it out. See, okay, so I don't want to deal with that. Like, see, and one more thing, the transistor that will be given, both the transistors should be almost same, okay? Because it depends on the area. So there are so many other things also on which the output current and the reference current depends. But here in the mirroring, if it has been given already that the both the transistors are almost similar, the VBE is same and the VB1 and the VB2 is same, the beta is very high, then you can directly take the output current as the reference current. Okay. And those types of questions only will be asked. I hope that is only discussed also, that the output reference current or the output current are same. Okay. Otherwise, it generally depends on the ratio of the emitter junction area of the transistor also. So area on the area also depends, like the transistor, emitter junctions area, all those things also come into picture. But that's fine. When I guess in the MOSFET it will be deal. Whenever in the MOSFET generally we deal like the ratio of the aspect ratio of the both the mid MOSFET also come into picture whenever we deal with the mid. But okay, it's fine. So here, let's for example, you have a question. Hmm, so the transistor Q1 and Q2. So for beta, for both the cases is very high, and VB for both the cases is 0.7 volt. Let's connect a diode here. So a resistance of 1 kilo ohm. A diode has been given to you. What else you need? You have to calculate current here. Do you need anything else? And for here also, this has been given already. If it is working in forward bias, it will be 0.7. What else do you need? Anything else do you need? No, right? This is zero point 0.7. This also will be zero point 0.7, and this will be minus 5 volt. You have to calculate I out. So this you have to
Is
calculate.
it 4.3 milliampere?
It's not 4.3. It's like I
Okay, sir.
guess
Okay, sir.
3.6 or something.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
3.6.
Yeah, 3.6 is correct. How did you solve? You would have taken this is first diode, and the
Yes, sir.
transistor Q1 will work as a second diode, right?
Yes, sir. I got 3.6 also. 3.6 milliampere.
Correct, 3.6 million. Okay. See, this is a one diode, right? This will work as a second diode. So this is 0.7. Here also you have a zero point 0.7, right? What else you need to calculate I out? You need IC1, right? If you have zero point 0.7 here, here also will be a zero point 0.7 drop, and here you have -5. So how much is left? 3.6. So you can just write it out as, so let's, for example, you have a resistance here. Okay, again a resistance here, and then you are connected with -5. Here also you need a current, right? So this is 1 kilo ohm, this is 0.7, 0.7, this is -5. You write the equation, you'll get the IC. Correct?
Yes, sir.
Yes, sir.
Yeah. So, but even though you just need to calculate IC, you need the current IC. To calculate the current I out, you need the current IC. And if you have that current, you'll be able to solve it.
Sir, I don't understand why not using 5 volt there? It is no
Why? 5?
positive 5 volt on I outside. You know,
I didn't, can you
5
just
volt
repeat?
that is right side that on the I outside 5 volt positive. That will not have any use.
Yeah, that is of no use, right? See, whenever you deal with the mirroring, right, concept, the current, see, that's the how, from here also, here you don't know anything, right? If, how will you use any loop or anything, right? There is no resistance, correct? And then you know the potential also, VC and all. Like, you don't know anything, right? How will you calculate I out here? So the best method is, if you know the current here, that will be same as I out here, right? This is the concept
Okay.
that you have, like we did, right? So the best method is to calculate the I current here. Whatever the current that will be getting here, that will be same as I out. Okay?
Okay.
Yeah. So in the mirroring, you will be given this type of a problem only. Okay, so let's try it out this. Here will not be using any diode. It's again you are giving some resistance, and you have a, you have to calculate this current I. This is given 0.7, 0.7. Beta is given very high. And it has been given. So information will be given like these are perfectly matched silicon transistor. Both are same area of that junction, emitter junction is same. So everything will be given. And then these are all the assumption that we make. Then you get the I current is same as I.
So here
So
I
how
will
will
be
you use the loop? I will do.
4.3 milliampere.
Yeah, correct. 4.3 is correct. So here you are using this loop. You can use, right.
Yes, sir.
You can. Okay, you can calculate IC1, and that IC1 will be equals to I. Anyone is having any doubt in this? Can somebody write the equation itself?
Yes, sir.
No. So
Yes, sir.
plus minus IC times 1 plus 0.7. This plus minus, right? Minus 5 equals to 0. So IC equals to 4.3. And IC you know, then this current is. Is it clear to everyone? Will you be able to solve it in the exam also, right?
Yes, sir.
Yes, sir.
No. See, so like all the questions will be similar. Like only the resistance value they'll be changing, and this is will be a standard question that can be asked in the mirroring. Okay, if you have been dealt with like different transistor, like the emitter area of the transistor one is different as to the emitter area of the second, then there can be different type of questions can be made from the mirroring. Otherwise, this is what will be asked, and all the cases the beta will be very large. Even though the beta, like you already know that the beta and upon beta plus two. So beta, even though the beta is in term of like thousands and all, the I out and I reference will be IC of the first one and I out will be same. Okay, so you don't worry about the IB because IB will always be zero because beta will always be whatever we are dealing, beta will always be high. Okay, if beta is less, then there is no use of this transistor. Okay, so this example you have similar problem. This example here the beta has been given as 700. So even if it is given like 700, 500 and all, you just think of as beta is very high and calculate it. So this is 9.3 kilo ohm. If you'll calculate it, putting the exact value, you'll mess up. Okay, always take like if beta is in given is like less more than some 100 or 200. Okay, you just take it as this is high value only, and then you calculate it. You just take beta as zero, like the current base current as zero, and then try to calculate everything else. Because see, IC and IC will be very comparable. Okay, and in the exam, if you have to calculate, mostly it will be given in the form of some range value, right? So it will not be wrong for sure. Okay, but even though whatever I can see, the paper also most of the like all the questions will be given the beta as a very high value. So and there is no point of asking that also if beta is small or something like that. Okay, yeah. So it will be clearly mentioned as beta is infinite or beta is very high to simplify everything. Okay. And one more thing I told you, right? Whenever you have been asked to calculate the VB or VC or VE, just above the, if you have been asked to calculate the collector voltage, just above the collector, you don't directly take this as a collector voltage. So if you have been asked to calculate the collector voltage, you have to calculate here the potential. You can't say 5 volt. Okay, if you have been asked to calculate the emitter, just calculate VB here. You can't say 0. If it is grounded, you can't say 0. Okay, and if you have been asked to calculate VCE, then VC minus VE. That means this potential has been asked. Okay, I guess this is making sense to everyone. So here also a similar problem you can just think of. You have been asked to
So is
calculate
it
the I current.
0.78 milliampere?
For this question,
Yes, sir.
0 point, how much you said? I guess 1
0.78.
milliampere. 0.78. No, here also you'll be doing the same thing, right? 9.3 times I, right?
Yes,
Plus
sir.
0.7
So there
is 10
VB
equals
will
to
be
0.
minus 7.3. So 0 minus 7.3. So we will
No,
find the
0, this
correct.
is 10 volt, right? It's minus 10 volt, right?
Yes, sir.
Yeah. So this will
Yes,
be
yes.
9.3 upon 9.3,
Yes, yes, sir.
1 milliampere. Hmm. Okay, so mirroring this type of problem, I hope we'll be able to
But
solve it.
here I out will be different, right?
Why?
Because here beta is given. Means
Uh,
like beta is
like
not
I told
valued.
you, right? If whenever beta will be given as more than some 100 or 200, you just take it as it. Even though the I out will be here 700 upon 702 times 1 milliampere, it's same as 1 milliampere, right? So no need to calculate that.
Okay, sir.
Yeah. So this is how generally you'll calculate. See, even though if you have been given something like that, let's say example, mm, the potential of 12 ohm has been attached there, and it is grounded. Here the potential of 50 volt as attached. This is 10 kilo ohm. What will be the value of IR? So here also the same method. We calculate the current. We'll be able to solve it.
1.13 milliampere.
Hmm. Calculate the voltage here.
Where, sir?
This 0.7. 0.7. What is the current I reference?
1.103 milliampere. 103 milliampere.
1.103.
1.13, sir.
1.13. Like minus 12
Yes, sir.
plus 1.13. Okay. Okay. So here also I out will be 1.13. Correct? So the drop that will happen here, the remaining drop will be the voltage. How much is that? 20 times 1.3.
27.4.
Yeah, correct, correct. So 20 times 1.13 will be here. The remaining will be here, right?
It will be 50 minus 20 into 1.13.
Yeah, correct. 50 minus 20 into 1.1 will be the value of B. Okay. Yeah, so this problem will be there from the uh, mirroring. Okay. So I hope. Okay. And the statement based problem, I already told you, right? Will be like true or false type statement. A common base will work like what? Common emitter will work like what? Or common collector. So what is that common base? Common emitter is what? Non-inverting, right?
Yes, sir.
Amplifier. This will be inverting. And CC is what? Buffer. So the statement will be like common emitter is working like a like inverting amplifier towards or something like that. Okay. So I hope you'll be able to solve it, right?
Yes, sir.
I hope I have written incorrect. This is inverting, right? Whenever you use common emitter, you directly minus GM times RC, right? So this is inverting, right? This is non-inverting. Okay, so you can just check it. Do not get confused in the exam, as I got. Okay, so or you will be asked like, what is the formula of transconduction conductance that you calculate? How do you calculate that?
So it's uh, IDC upon V thermal.
Hmm.
That is also
I
a gain.
yeah,
I
upon
say
V
on
thermal.
VT.
Yes. Yeah, correct. What else? Yeah. So at least for the BZT point, like we have tried solving the, and this is what will be asked also in the paper. What else is remaining? The rectifier circuit are linear or non-linear?
It's linear, sir.
Rectifier, the clipper circuit that you deal, if you have a diode, that will be a linear or non-linear?
Non-linear, sir.
Yeah, non-linear. Okay, and whenever you apply DC plus AC voltage, right? What does that capacitor do?
Capacitor
Yes.
block the DC current and
Allow
go
AC signal.
passes the AC.
Correct. Yeah. So that's the reasoning behind the capacitor, right? So in this all reasoning you should be knowing. Okay. Yeah. So yeah, good to go. If you are able to solve whatever the problem that we have solved today, if you are able to solve at least BZT part, you'll be able to do all the problems. Okay. In the next session, we'll just deal with the Clipper basics, and the Laplace will solve the problem similar to, and try to solve at least the previous term paper, one previous term paper. That will give you more insight. Like if you're solving the pattern is almost same, right? So you can just practice it out the previous term paper if you have. Okay.
Yes, sir.
If you have, yeah, you can share it in the. Okay, let's share it. Maybe in the Saturday session, we'll try to solve it. We have tomorrow also, so tomorrow also we'll be solving the problem itself.
Okay, sir. I
So
have it.
any
I'll
doubt
send
that
you.
you faced? Yes. Hmm. Yeah, Aniket, you were asking something, right?
Sir, can you
Yes, sir.
provide?
Sir, first of all, if there is any beta given for the transistor, how do we solve that? And second question is more general question, no like course related. So it's about if there in the upcoming terms, if there is any paper that we have to write in like in physical paper. Basically, we are
Mm-hmm.
doing computer-based test right now.
Mm-hmm.
And I got a mail regarding this physical paper thing.
For
So,
which course? Yeah, you will be getting like analog you will be taking, right? So that is you'll have to write the solution. Subjective type of a paper. Match 2 also is subjective, I guess. Yeah, match 2 is subjective. Last time when I was taking that was subjective. Last time it was objective, but again this time it became subjective.
okay, so it has always not been a subjective paper.
Yeah, yeah. Some of the paper is like subjective also, like sensors and all. All the courses in diploma levels are most of the paper are subjective. You'll have to write the solutions and everything. Yeah,
Okay,
like
okay.
for
Thank you, sir.
DSP, you have subjective, analog is subjective, sensor is subjective, match 2 is subjective. Okay, yeah. Hmm. So regarding
So the
the
beta
beta, see
related
beta
question.
mostly it will not be given. If you have been given, how
Sir, your voice is breaking.
yeah. Is it fine now? I guess it is fine. I didn't change anything.
Yes, yes.
Is it fine now?
Yes, sir, it's fine now.
Am I? Yeah, yeah. Okay. 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 Let me see. I have any questions. Okay. Last time when we solved. Okay. Beta. Should be okay. Last session we solved right one questions where we were having something like
Yes,
that.
sir, but I didn't understand.
Both are grounded. Hmm. Here it let's say example you have been given beta 75. And then we will be asked to calculate, let's say example, this question, yeah, beta has been given here, and then let's say example voltage here is 15 volt. Did you solve this question last time? Last, I guess no,
Yes,
this
sir.
we
Yes,
solved
sir.
right, where you have
In
to
the
calculate
previous
the
session,
ratio of,
you solved it.
right? Hmm. Yeah. So here you can take the help of beta. Here the beta will also help because you need two equations, right? Are you getting me or not?
Yes, sir.
Here there will be some beta ID also, current. Or you want to solve the same problem with the beta value.
Yes, sir. Same problem with beta value.
Hello, can you hear me?
Yes, sir. We can hear you. If you solve the same problem with beta high value, sorry,
I
low beta value.
Hello, sir. Can you hear me?
Yes, Aniket, I think Sir left. Maybe he will join again.
Okay. What is the value of IC in term of beta? Beta times IB, right? Can you hear me?
What
Yes,
did
sir,
you
we can
do?
hear you.
What?
We can hear you.
In the meantime, you
Yeah.
got disconnected. So can you repeat again?
Yeah. What I'm saying is you have to the same the problem what we were having 12 volt and all everything you have to calculate VC, right? Here, let's
Yes.
say example I'm taking beta as 50. So if I'm taking beta as 50, then IC will be what? Because there will be some beta current, base current also, correct?
Yes. Yes.
Yeah. So what will be
Beta
the
times
what is
IV.
the IC is what? Beta times
Yeah,
IB, correct?
beta times IV.
Oh, yeah. So now what all equation you can use it? How will you calculate the value of I? You have to calculate now. You need IB also.
Yeah, so we have to use loops here, mesh analysis.
One you can use even with the Thevenin you can solve, but one let's say example you are using going from here to here. One this is grounded. So one equation you can write it as like this. What is the equation? Minus 12 plus 8i plus 2 times I minus ib equals to 0. The other equation you can write it here. What will be the value? Minus 2 I minus ib plus 0.7 plus 0.2 times IE equals to 0. How can you write IE in terms of IB?
Then I equal to IB plus IC, and IC is equal to beta times IB. So
Yeah,
IE is equal to 1 plus beta times IB.
right. And this you can write it as IB equals to IC plus IB, right? And IC will no, write it as IB upon beta plus IB, correct? Equals to 0. So again, you'll be having two equations in term of I and IB, right? Beta you
Yes.
already know, right? So minus 2 I minus IB plus 0.7 plus 0.2 times IB plus IB upon 50. IB upon 50. This will be 51 IB upon 50. Correct.
Yes.
So see here also 51 IB upon 50. So almost like IB only. You can just write it as IB here and calculate the value of IB.
Okay. Okay. Okay.
Correct. So somewhere you can do the approximation and calculate, and you'll be having an equation in the form of I and IB. You can solve it till get the value of I and IB both. And if you get the IB, then so everything you can calculate IC because all the equation you can write it in the form of IB and then that's all.
And how, sir, how to do it with Thevenin?
Thevenin, you can do it like you can just this equivalent. What is this? If you just look at from here, what will be the Thevenin equation? This will be something like that, right? Potential, potential across 2 kilo ohm. But again, you can't write it the Thevenin because you have IB, right? If you have IB, then how will you write? Like, then you can't write.
Okay. Okay.
Yeah. If you don't have, then you can directly write the like the voltage divider rule. You can calculate the voltage across 2 kilo ohm, and that will be the Thevenin voltage, and the resistance you can
Okay.
directly write
That
it as.
cannot be done here because there
Yeah,
is
that.
IB.
Yeah, yeah.
So Thevenin can only be applied if beta is very high.
Yeah, then current will be zero, right? So how do you calculate the
Yes.
Thevenin, right? If the current across that load, you just think as the current across that load is zero, right? The current when you calculate the Thevenin, right? You take VOC as zero, right? Open current. When it will be
Yes.
open current when we don't have the current in that.
Okay.
Okay.
But in case of this, we can apply right now.
Right now you have voltage base current, right?
Yes.
Yeah.
So the base current will be the open current.
No, that won't be open, right? You have some current, right? If it is, then we are approximating that as a zero, right? Then you can directly calculate, right? See, when you open current, it means what? There is no current in IB, right? If you have current, then how will you? Did you get the
No,
idea
like,
or no?
sir, say if I am applying the Thevenin across this 2 kilo ohm resistance, or do I
Okay.
have to apply somewhere
Yeah,
else?
yeah, yeah, yeah. Correct, correct, correct. If you are applying at 2 kilo ohm resistance, right? See, then you just take it as the IB as zero, and then you calculate. There also, I
Okay.
guess you can calculate it. Yeah. So you just take it as IB because that is open current only, right? Then you'll be having a resist RTS, so it's fine. I guess the RTS will be 8 parallel to 2.
Yes, sir.
Correct?
How you have calculated this RTH?
Okay. See, how do you calculate RTH in Thevenin? You put all the
By
voltage as
disconnecting the resistance, load resistance,
no load resistance by disconnecting all the dependent
voltage
independent
source and
source.
current sources. We disconnect all the voltage source and current source, and
Correct?
the load resistance across which we are calculating the Thevenin is also disconnected, right?
Yeah. So this is your load, right? If this is your load, this is short circuited. So you're left with 8 kilo ohm and 2 kilo ohm. Both are in parallel, right? This is also, huh?
Okay, okay,
Yeah.
okay.
So 8 parallel to 2, that is the resistance. See, even with the current, even with the
But sir,
current IB also
what
you can
about
calculate.
1 kilo ohm and point 2 kilo ohm?
Which 1 kilo ohm?
The right one, from which the IC is
No,
going.
but you are looking from here, right? You are just looking from here. So this whole BJT is your load.
Okay.
So see, you are calculating. Let's say example, you have this BZT. And one more thing, I guess I mistakenly said it right. Even though if you have IB, right, whenever you calculate the voltage, you just assume that as a open, and then you calculate the voltage V Thevenin. Right? Even though there is a current and all, we don't worry about that. You can
Okay,
calculate the
okay.
V, or like V Thevenin for those cases also. No problem in that. So I guess I see, how will you calculate? I'll tell you. See, you are calculating from here, you're just taking BJT as a load, right? You just want
Okay.
to make an equivalent circuit. So the equivalent circuit will be look like this is the BJT, this was your load. So you'll be having a Thevenin resistance, RTH, and you'll be having a Thevenin voltage, VTH. VTH, you can calculate the voltage open source, like the sort of open, like you're just
Okay, all
assuming
the
that
source
IB is zero.
disconnected.
Correct,
No,
correct.
that is
So
for
the whole
RTH, and VTH is by
VTH
like,
is V open
yeah,
source
the
voltage. You
load is
just think
only
as
disconnected.
no, no. See, you have this BJT, right? Let's for example, this is a BJT RC. You have connected with VCC, and this is R1. This is R2. This is RE. Okay, and this circuit you have to replace with Thevenin. Okay, this BJT you are taking as a load. Okay, so how will you do? This is the circuit that you have. The circuit you will be having this resistance RC, and this voltage you will be having VC. So this both are same, and R V Thevenin and R Thevenin you have to calculate. R Thevenin is simple,
Okay.
R1
Yes,
parallel to
yes.
R2, and VTH is VOC, open current. See, VTH also you can calculate, right? If there is no IB, then though it's like just a voltage divider.
So VOC is the
RTK
open circuit current, but open circuit voltage, but there is no source in the original circuit, right? In
VCC is there,
from
right? It's some
okay,
reference voltage, right?
okay, okay, okay.
Yeah. So if you'll just write it, See, VTH also you can calculate. VTH, let's for example, this is the equivalent circuit, right? You calculate VTH. VTH will be in term of IB. If there is no IB, then so it's very simple. Okay. If in term of IB, you'll have, because there is some IB you are thinking, right?
Yes,
Just
yes,
write it as it
got
is.
it, sir.
So VTH will be minus VTH plus IB times RTH plus VB, correct? And then you have a resistance here also, RE, right? So we'll be having 1 plus beta times IB RE. So VTH will be this one, IB RTH plus VB plus 1
Yes, sir.
plus
Basically the same thing
beta.
in some different way.
Correct. So this will be the VTH. Yeah. So I mistakenly said that you can't calculate. You can calculate like VTH. So you can do it for any circuit, right? So there's no problem in that. So this will be the VTH if you have IB. And if you don't have IB, then so open current will be what? Like, it's like IB is zero already. So VTH will be the voltage divider rule. Say you can calculate the R2. The voltage across R2 will be the V open current.
Yes, sir.
No
Got it.
voltage. Right? Yeah. Got it. Yeah. Okay. So let's meet Saturday. Tomorrow also the session will happen.
Sir,
Yeah.
sir, can you solve graded assignment question number 3? Like I didn't understood one thing, so I just wanted to ask that.
Okay. Graded assignment 8.
Yes, sir. Graded assignment 8, question number 3.
Hmm. The deadline is over. For
Yes, sir.
week
It's
8.
on yesterday.
So the DC current I of the circuit is,
Sir, can you share that screen?
one second, I'll just take a screenshot and share it. One second. Uh, can we just, I have a meeting now. Can we meet today? Okay, so can we meet again?
Sir, I can share that question in that G space with my query.
One second, one second. Uh, I just forgot I was having a meeting. No, no. Okay, okay. Ananya, I'll just share the solution with you, right? Or maybe,
Yes, sir. I'll send my
what's the doubt
query.
here? Just give me.
Sir, in
No, no,
this.
you have already said. Can you just tell me what's the doubt here?
Okay, sir. Sir, in
So you
this.
have to calculate the DC current.
Yes, sir.
Mhm. So you the capacitor you'll remove, right? That will be open. Everything here will be open. So what is the your circuit will become very simple, right? You have to calculate DC current only,
Yes,
right?
sir. But
So it will be
sir, at
E2
that
will be
time,
removed, open circuit. No, no, just so 18 volt is there, right? 3.3 kilo ohm is there, where you have to calculate the current, right?
yes, sir.
Okay, 1 second. I'll just share it from my laptop. Wait a minute. Can you see my screen, right? This is visual, right? This question only, right?
Yes, sir.
Okay. So see, 18 volt is there. This C2 will be open, right? This will be open. So you'll be having a simple circuit, right? Where you have just a normal circuit, self-biased circuit, right? So 91 plus 110, so 200 whatever. There you have one resistance here, one resistance here. That's it, right?
Yes, sir. So,
What's
sir,
the?
at that C1, when it will get open
Huh?
circuit, then there will be zero voltage, right?
Yeah, yeah, 0 volt. Nothing will be
So,
there.
so this will be in
No, no,
forward
not
and
zero,
reverse,
not
right?
zero, not zero. No, not zero, not zero. This is open, right? This will be open circuit. There won't be anything. So this just be 91 kilo ohm and 110 kilo ohm. And this C2 also will be open. There is no, you can't ground this. Yeah.
Yes, sir. What
Okay.
voltage will be at
So
VB?
VB, there is no voltage. You just have VBE 0.7. That's it. Okay. I'll say the solution. Okay. Don't worry. Huh?
Okay, sir.
So
Okay,
I
sir.
have a meeting. I have to join it. Yeah. Okay. Thanks. Thanks
Thank,
everyone. We'll meet again. Yeah. What?
thank you, sir.
Okay, thanks. Thanks everyone. I'll share the solution with you. And thanks everyone. Just we will meet again. Yeah.